Okay. All right. So today we are going to look at the geometric progressions. We're going to look at geometric progressions today. So okay, as usual, let us just move on to see what it really means when we say the geometric progressions. So by definition, a geometric progression is a series of terms where there is a common factor between terms, which is called the common ratio. So a geometric progression, we're saying this is a series of terms where there is a common factor between terms, which is called, that common factor is called the common ratio. All right. So we are going to look at this ratio. We're going to look at this ratio and see how we can find it, see how we can really find that ratio. Just accept these guys who are waiting. Okay, so let's jump into another slide and see a further explanation of the GP here. Okay, here we are. So let's just examine further about the GP. Okay, further about the GP. So we are saying a further explanation of a geometric progression. So this is a series of terms where there is a common factor between terms, like I already said. The definitions are very, very important because once you understand your definitions, you'll be able to get answers right from a definition. So I encourage you to just understand the definition. So this common factor is called the common ratio, and it is found by dividing any term of the series by the one following, immediately following it. So how do you find the common ratio? Here we are told in this statement that the common ratio is found by dividing any term of the series by the one immediately following it. For example, let's look at the examples below of the GP. So look at this first example here, 2 plus 4 plus 8 plus dot plus. So common ratio there is going to be 4 over 2, which is going to be 2. So here they've chosen to use, these guys chose to use 2 plus 4. 2 is followed by 4. So for us to find the common factor there, we are going to say 4 divided by 2. Or if you want to use 4 and 8, so you're going to say 8 divided by 4, which still is going to give you the required common ratio there. So the same applies here. 1 over 2 is followed by 1 over 6. So for us to find the common ratio, we divide 1 over 6, divide 1 over 2. Or we can divide 1 over 18, divide 1 over 6, because 1 over 6 is followed by 1 over 18 there. Okay, 1 over 18 there. So that is how we find the common ratio. Common ratio, very, very important. Please, very, very important. Let's just look at the general GP, just like we looked at the general AP. So we can also look at the general GP there. Just admit some frames. Okay, you are most welcome. Those that have just joined us, you are most welcome. You are most welcome, please. Those that I know, to some of you, we did this. Please let it serve as a revision Where you did not understand, where you did not understand, then please can you mute your mic, Kundananji? Where you did not understand, then we are going to be able to learn, and you are going to revise. Okay, so let's look at the general GP there. Okay, the general GP. So the general GP is given by this expression here. This expression here, I'm sure you're able to see it. The expression A plus AR plus AR squared plus AR just a minute. Okay, so A plus AR plus AR squared plus AR cubed plus AR4 plus dot plus ARN minus 1. So you would discover that in this, when we say A in the general GP, both in the AP and in the GP, when we say A, what we are just looking at is the first term. So in these examples given there, our A is 2. And in this second example, our A is 1/2, because these happen to be the first terms of these particular GPs. All right. So now, with a GP, we are looking at a common ratio, So T1 is going to represent the first term. T2 here is going to represent the second term, like you can see in this yellow box there. So T2 is equivalent to AR, and the T3 is equivalent to AR power 3. So AR3 is the same as, AR2 is the same as T2 there, T3 rather. So when we continue with this pattern, you would discover that as we ascend in the powers, as we ascend in the terms, we are reducing the power by 1. As we ascend in the terms, we are simply reducing the power by 1. Okay, we are reducing the power by 1 as we ascend in the terms. Please take note of that. As we are making an ascension in terms, we are having a reduction in power by 1. We are reducing the powers by 1. So the term, this last term here, I'm sure you're able to see that. So the term ARN minus 1 is what we call the general GP, or the nth term of a GP, the nth term of a GP. Here it is down here, okay, down there. The general term of a GP, the nth term of a GP. Please, this is what we do. So if we say T1, we are at AR, we are at A. Then T2, if you are told to find the second term, we are simply saying you are going to use the expression AR. If you are told to find the third term, we are saying we are going to have an expression AR squared. So fourth term, it will be AR power 3. Fifth term, it will be AR power 4. Sixth term will be AR power 5. 10th term will be AR power 9. 20th term will be AR power 19. All right. Kima, what do you think the 35th term is going to be? Kima, can you come in and answer that question? Kima? Kima? Kima?
Can you repeat again what you said about the terms? I didn't understand.
Where didn't you understand, Kim?
Just everything here on general GP.
Okay, so on the general GP, pay particular attention. We are saying the first term is always A, okay? the first term is always A. The second term is A power A times R. That is the second term there, A times R. The third term is A times R power 2. So look, this R here is raised to power 1. Okay, raised to power 1. The A here, the A you are seeing here is always the first term. The first term. So we're saying the first term multiplied by the ratio, the common ratio. Even here in the very first term there's an R. So the R there is raised to AR, AR 1 minus 1, which is going to give you AR 0. So AR 0 is going to produce, AR power 0 is going to produce a 1. No wonder here the R is not indicated there. Okay, I hope you are following that. So here we are saying now we are at AR. So this is AR2, T2, the second term. Second term, T2, is the same as AR power 2 minus 1. 2 minus 1 is the same as 1. No wonder we have the R there, because this R in the actual sense, it is raised to power 1. So no wonder we've got A times R power 1. Then third term is going to be A, the first term, times common ratio. So A times R, 3 minus 1. 3 minus 1 is going to be 2 there. No wonder we are having a 2 there. Are you following? So we are saying A, which is the first term, multiplied by the common ratio, times, since we are at third term, so we're going to say 3 minus 1 in the power. Okay, in the powers. So 3 minus 1 is going to produce a 2. So no wonder we are saying the third term here is going to be A times R power 2. All right. So this pattern, as we are ascending in the terms there, you are going to discover that as we are ascending in the position of the terms, these are position of the terms, we are reducing the power in R by 1. So T4 is going to be A, which is the first term, times common ratio to the power 3. If we are at T5, we're going to say the result or the expression for T5 is going to be A times R power 4. We are reducing the R by 1. So if we are at T7, T7 is going to be A times R power 6. All right. So now, what will be the term for T35? 35 term, the position, the T35. What is going to be the general term for the 35th term? Kima, come in again. Kima?
I'm not really sure, but maybe it's AR to the power 34. I'm not really
Great.
sure.
That's great. That's great. That's the thinking that you need to have. So at whichever position, the position of the term, if you are dealing with a GP, you are just reducing the R by 1. If you can have that understanding, then that's great. Because they're going to be useful, because there's a point where we're going to use these. So if you understand that if I'm at T5, then I'm simply having an expression, T5 is equal to AR power 4. If I'm at T10, I'm simply having an expression, T10 is going to be AR power 9. If I'm at T20, then T20 is going to be AR power 19. If you have this understanding, then you are not going to have any challenges. Are you following that? Please, I want you to be used to this kind of understanding. Whenever we have T, maybe the particular term position that we want, then we are simply saying, let us do that term, let us reduce the term by 1. Then you are there. Okay. I hope you are following that. Let me just admit this, guys. Please, let's observe time. Okay, let's now move on. Let's move on. Let's move on. Let's move on. So let me just jump on to another slide because I believe here we have had enough and you have understood, isn't it? Let's look at an example. Okay, example one. For the GP, 2 plus 6 plus 18 plus dot dot dot, find the 10th term, find the 17th term. Have you seen how simple these things are? So for this particular GP you have been given here, 2 plus 6 plus 18 plus dot dot dot. You've been told to find the 10th term and you've been told to find the 17th term. So already, like I was mentioning, if we are looking at the 10th term, we are simply looking at A times R power 9. Are you following that? So the general term is given here. This general term is given there. So Tn is equal to A R n minus 1. So since we are saying the 10th term, meaning our n there is going to be 10. So T10 is the same as A times R n minus 1. What is n minus 1? It is just 19. I mean, rather, it is just 9 there. So 10 minus 1 is 9. So this A here is always the first term of the given GP. So here we have been given this GP here, 2 plus 6 plus 18. All right. The only thing that we have remained with is to find the common ratio. So how do you find the common ratio in a given GP? You simply divide the way the terms are followed one after another. You divide, for example, here you divide 6 divided by 2. If you've chosen to use these two guys there, if you've chosen to use 6 and 18, then you divide 18 divided by 6. Then you're going to have your R there, which is 3. Okay, which is 3 there. So once you have your 3 as your R, you just substitute these guys into the common into this guy there, the general GP, and then you have your solution. And the beauty about this is that you've been allowed to use a calculator because these numbers are just too huge. Okay, is that understood? Dingiswayo, have you understood?
It's understood. Yes.
Huh?
Yes, I've understood.
I'm glad to hear that. Michael, have you understood Muzungu?
Yes.
Okay, I can hear that bass voice. Great. So it is very easy now for you to find the 17th term, isn't it? Let's move on. This one, it's simple as well. Just do like we have done here. Very simple. You come up with your answer there. Let's jump on to another slide.
Okay.
All right. So here, example 2. The third term of a GP is 9. All right. And the 10th term is 19,683. Find the common ratio. Right. Find the common ratio, find the first term, and then find the 80th term. This is very interesting. This is very, very interesting. Like I said, look at this. That's the importance of you understanding when we say this particular term, maybe third term, you know in mind, when we look at third term, what expression are we looking at? Third term, we are simply looking at AR power 2. Dingiswai, what will be the 10th term? What will be the 10th term there, Dingy?
It's 19,683.
I want an expression for 10th term. This is the value for 10th term. Now I want its expression. Whenever you come at you come to the term, to this 10th term, what should come in your mind? A times R power what?
It's 3, then 10, which is equals to A, then R n minus 1.
So meaning when we get it directly, T10 is simply the same as 8 times R power 9. Are you following?
Yes.
Timo, I've seen your hand is raised. What is it?
No, it's okay. It's fine.
Okay, that's great. So please look at this. I want you to develop that understanding of saying, the moment you say third term, then the expression for third term should immediately pop up in your mind. Third term is the same as 8 times R power 2. Okay? 10th term is the same as 8 times R power 9. Now, you've been given these values. So the value for 8 times R power 2 is 9. And the value for 8 times R power 9 is 19,683. Then it will be very easy for you to come up with the common ratio. It will be very easy for you to come up with the first term. It will be very easy for you to come up with the 80th term. Let's just jump into the solution and see what we are supposed to have there. Right, so here we are. So T3 is the same as 8 times R power 2. But the value for T3 is 9. So we are saying 8 times R power 2 is equal to 9. That's equation 1. Then T10 is equal to 8 times R power 9. But we have been given the value for T10. T10 is equal to 19,683. So therefore, 8 times R power 9, which is T10. So this is the same as T10. 8 times R power 9 has got this value there. So you can see that we have these two equations there. So dividing equation 2 by equation 1, the greater number should always divide the smaller number. All right. So here we have got AR9 divided by AR2. All right. We are going to have 19,683 divided by 9, because we know that AR9 is here. AR9 is this guy there. And AR2, which is our third term, is 9. So therefore, A and A there will divide. By indices, we know that R9 divided by R2, we are simply reducing this power by 1. So R7 is going to be 21,187 there. That is going to be our R7. So the 7th root, this is R power 7. Now, for us to find R, we have to find the 7th root. The 7th root of 21,183, which when we key in on our calculator, it is going to produce a 3 there. So the common ratio is therefore 3. Okay, 1 has been found. Now, if you find the common ratio, then it is very easy for you to find now the first term. It is very easy for you to find the first term. You can use whichever, you can either use this guy, or you can either use that expression there. You still come up with the required solution. Okay, you still come up with the required solution. So let's just use the first term there. So A times R squared is equal to 9, meaning third term, T3 is equal to 9. All right, now here we have calculated the value for R, which is here. Okay, our R is 3. So we are saying A times R power 3 is equal to 9. So A R power 3 is the same as 9. So we're saying A times 9 is equal to 9. So to remain with A there, you divide both sides by 9. All right. So when you divide both sides by 9, you're going to end up with A as 1. So the first term is 1. All right. Now, if you have the first term as 1, then it is very easy now for you to complete the problem there, to find any term, since you have the first term and you have the common ratio. Now you can use this guy there to come up with whatever term we've been asked to find. As long as you have your first term and you have your common ratio, then it is very simple for you to come up with whatever term you have been asked to come up with. It can be T hundreds, T 1 billion, T 1,000, whatever. You still come up with that guy correctly. Are we following? So here we've been asked to find the very simple thing. What is the eighth term? So the eighth term is the same as 8 times r power 7. 8 times r power 7. Our a, we have just calculated our a as 1 there. And our r, we just calculated our r as 3. So meaning that T8 is going to be 1 times 3 power 7, which is going to take us back to 3 power 7, which is the same as this guy there. Okay, this guy there, 2187. So the eighth term is 2187. Kima, is that understood? Kima,
Yes.
is that understood?
Yes.
Very good. Very good. All right. As I'm checking on my time, I'm just see, because this meeting will be cut short. Okay, the geometric mean. The geometric mean. So let's look at a geometric mean. If the terms A, B, and C are 3 consecutive terms of a GP, then B over A is equal to C over B. All right. So what is the meaning of this? This simply means here between A and B, the common ratio, if we are to find the common ratio there, we are going to say R, okay? R, the common ratio between A and B is the same as R is equal to B divided by A. So if we are again to find the common ratio between B and C, here, between B and C, we are simply saying R common ratio is going to be C divided by B. So this here, it is representing the common ratio between A and B. And this here is representing the common ratio between B and C. I hope that is understood. So this equation here, you are going to discover that both sides there is a B. So meaning we can solve this equation for B. So to find the solution for B there, we're simply saying we cross multiply there, we're going to have B squared is going to be A times C, AC, right? AC. So we are almost running out of time. So anyway, we've got some good 9 minutes. I think we can finish. Some good 9 minutes to go. We can finish this. So B squared is going to be A times C. A times C. Meaning for you to remain with B, you're going to say the root of AC. B is going to be the root of AC. All right. B is going to be the root of AC, which is great there. So one thing that you're going to discover is that this quantity here, B is equal to root AC, is what we call the geometric mean between A and C. The geometric mean between A and C, meaning between the first term and the third term, there is a geometric mean of B there. Okay, so always we know that example is the best teacher. Let's just see this thing in an example. So example, here we are. The numbers 2, x, 18 are 3 consecutive terms of a GP. Find the possible values of X. Now, here we are looking at terms that are consecutively following each other, meaning terms following one after another. So 2, X, 18 are 3 consecutive terms of a GP. Find the possible values of X. Find the possible values of X. Take note, you were saying possible values, not just the value, but possible values. So meaning that when we go by our formula, this is going to represent B. This is A, this is C, okay? And this is B. So when we go by our formula, we are saying B squared is A times C. So meaning here our B squared is the same as X squared. So X squared is going to be 2 times 18, right? That is what we have there. So X squared is going to 2 times 18, all right? So to remain with X there, we're going to say, we know that 2 times 18 is going to produce 36. So X is going to be plus or minus the root of 36. Therefore, X is going to be plus or minus 6 there. All right, that's going to be our X. Okay, so in the remaining 6 minutes, let's just see if there is something else we need to do. All right, so this is very simple and short. GP is very simple and short. Let me just keep it this simple. Next week, we have to be looking at the sum of a GP. If God gives us life, we have to be looking at the sum of the GP. I think that would be that would be the last thing in our topic of APs and GPs. So what remains for us is an exercise. I hope you guys have understood this thing. Anyone who is behind, before I give you an exercise, anyone who is behind, in the remaining 5 minutes, we can have an exercise. Anyone who is behind on what we have explained on the GP and on the general GP, on the general GP and on the geometric mean, anyone who is saying, I'm still behind. Lukundo, Nakazwe. Nakazwe? Nakazwe, come in. Is that understood? Kundananji, is that understood?
Yes, Mr. Kaonga.
Okay, all right. So if that is understood, and with you guys, this is I think you have understood now more and more. So before I give an exercise, I've asked the question, Lukundo, have you understood? Is Lukundo in? Lukundo? Okay, let's not waste much of our time here. Let me just give you an exercise in the remaining minutes, please. So answer all the questions below for practice. You can answer all of the questions, but not that only selected questions will be marked. Question 1, part 1, and part 2E. I'll just mark the E's there. Okay, these must be answered. Then question 2, I'll just mark question A and H. So these you must answer them. Then question 3 up to 8, all of them should be answered. All of them should be answered. Right. So question 1, there you are. Find the indicated terms of the following GPs. Find the indicated terms of the following GPs. So I'm interested in E. 1 plus 1 over 2 plus 1 over 4 plus 1 over 8, dash, dash, dash. So can you find the 7th term? Can you find the 10th term? Then in part 2 here, I'm also interested in E. 2 plus -4 plus 8 plus ... So here, can you also find the, let me see, find the nth term. Here it is now for you to find the nth term. You need to find the nth term there, okay? For this one, give us the nth term. What will be the nth term? What will be Tn? Tn, okay? What will be the formula for Tn? So here we are just calculating formula. So for this part 2, we are calculating the formulas. The Tn here, Tn there, Tn, Tn, Tn there. So this is for formulas. This is for terms, right? I hope you've understood what you are supposed to do. So find the number of terms in each of the following. Find the number of terms in each of the following. So here I'm just interested in A and H. A and H. Find the number of terms in this GP there. So you discover that here the nth term has been given, the Tn term has been given there. So very simple, just use these into fuse these into the general GP, and you'll be able to come up with the solutions. I'm interested in this one, A and H. Find the number of terms. Next. So question 3, we have the GP there. Okay. Find the positive value of X and find the 12th term. So you discover that this one is the one we're going to use the concept of what? The geometric mean. The geometric mean concept there is going to work. Okay, I have to end this meeting here because my time is up. I have to end this meeting here. However, as usual, I'm going to send the PowerPointed version of the recorded video, rather the recorded Zoom. I'll send it over to you, those that participated and those that missed, so that you can follow along as we, as you just do your revisions. All right. God bless you all. It has been lovely listening. Learning. You've been good listeners, and really I appreciate